Hey Chuck, I just wanted to run you through some of the stuff that the sheet does here. This is pretty straightforward. It just calculates your gallons per day, and then this is just the hours run. We do have a check here that if any of these numbers are higher than the average by a certain factor, I have to look on the sheet to see what that is. It will throw if it's 3 times higher, then it will throw it into the yellow. So these are all high because of, there's no SBR number 1 pump. But normally these would both not have a highlight over top of the runtime hours. And it's just looking at the average runtime, the max, the min, peaking factor. And typically what we'll see is like a peaking factor for flow. You'll see that same peaking factor for, the runtimes on the screen and then on these pumps as well. So that's the normal behavior. Obviously, with having one of the pumps out, you have a little bit that skews kind of the numbers here in the shading here. So that's that one. On the chemical, same deal. So just have the inches measured down on the tank. That converts it converts the feet in inches measurement or just inches measurement to inches. So in tenths of a foot or in tenths of an inch, and then it will calculate the gallons used. So we can just kind of generally see that trend of gallons used. Then again, the average meets max peaking factor. Again, you typically see that matching somewhat close to the peaking factor of the flow coming in. Just an indicator there, and then the average amount used, or approximate total average used in each tank, things like that. In the SBR, just our standard measurements. Now these cells go green and red based on what are good and not so good numbers. So again, that's the conditional formatting handles that. So if we have a value here where the pH is kind of out of spec or getting close to being redlined above or below, because pH is a mean value, then or a value that we want something kind of in the middle, then it will automatically trigger yellow. Just like in SkyTop, if it's yellow, it's kind of cautious. If it's red, you're dead. Not you're dead, but you know what I mean. We got to get it back if it's in the red. It's usually out of spec, or if it's pH, that's mean danger zone. Settleability doesn't have anything. This is just the tank. When you get the mixed liquor from the tank, there's some stuff that goes on with this. So with the mixed liquor and the tank, the water height level in the tank, when you measure the mixed liquor, which you can get this direct on the PLC monitor itself, that on the overview page, it will calculate the goal wasting time. So this kind of gives us a sense of, hey, to get to this number, the 2100, which is our goal MLSS, what should the wasting time be? And obviously, we want to get this where there's a lot of fluctuation going on here in August, but normally we want to see this bounce between 1 and 2 minutes, and that gives us a sense of should we be trending it up or trending it down. It's not friggin' rocket science. You can kind of see what the goal is and where you're at, but this gives a number that you can put into the auto wasting if you start seeing it go up. And usually want to be seeing it go up by like 1 or 2 minutes that way. Then what we're capturing here is the actual wasting time set. So hopefully this will just get, ultimately in the future, like 1 minute, 1 minute, 1 minute, 1 minute, 1 minute, or 2, 2, 2, 2, 2, 2, 2, 2, 2, 1 minute, it'll just be more regular versus this bouncing all over the place because of this disruption. This here is just the wasting, based on the wasting rate, which is how quickly the pumps feed that in. And then we'll come back to this food to mass. We'll talk about that here in a second. But we have this daily phosphorus. These are just the measurements in the tank. And then, again, we have the yellow, green, yellow, red scheme for where things are on target, good. Yellow is getting kind of a little close to the edge. And then whatnot. Same thing for SBR2 as we just reviewed for SBR1. And then this goal wasting can vary throughout the season. So how do we know when to vary this goal wasting? The target is set by the manufacturer at 2100. I think it's 2100, 2200. I think it's 2100. But how do we know to move that up? So in the winter, it typically goes up a little bit. In summer, it usually goes down. And that really has to do with the food to mass ratio. So when we go back into here, now this is just the lab results from the effluent aeration tank. Again, temperature, pH, same deal, so on and so forth, all the way across. And same thing with the highlighting scheme there. But I do get, when we get the lab results back, which is always delayed by a week or 2 weeks, something like that. I will go back and put these influent BOD measurements in here. And then that can be used along with the mixed liquor amount here, and it will give you your food to mass ratio. That food to mass ratio for this design of this plant should be a 0.7, as it says right here. So as this number starts to creep up or down, it's actually inverse. So if you want, for example, if this number starts to creep down, and say we just change this to 2100, you'll see that that number bounce up. So a lower food to mass ratio means you're going to need a lower mixed liquor in the tank to bounce that back up. A higher food to mass ratio means you want a higher MLSS in the tank to bounce that down. So you can see here, if I put this like 2900, this will lower the food to mass ratio there. That's kind of the seasonal thing that you generally see will change there, just based on that influent BOD measurement. The other thing that I guess this last sheet here, this just is a sheet to calculate that goal wasting time. And the final piece to that is that it's making an assumption, which is documented up here, that they're running mixed liquor to waste mixed liquor ratio. So this is the mixed liquor while it's in aeration. This is the mixed liquor of the stuff that's wasting into the digester. That is around a 2.7, the ratio between the two numbers. That number is a general trend that we see based on historic data. But if you grab a waste mixed liquor sample, meaning that the sample is taken from the header piping as it's in waste or wasting off the tank. So it's the mixed liquor, in after settle off the bottom of the tank going into the digester. That can calibrate this number here, which will then calibrate your target wasting per day. And that all happens over here. So if there is a waste mixed liquor sample done here, you can see we have one here, here, and here, it will calibrate that number. So you can see right here, it's not, in this month, we were getting a higher concentration, which is good in SBR number 1. They weren't getting on SBR number 2. So really the waste mixed liquor was the ratio between the two is a 3.6, not a 2.7. So that was trending up. That's a good thing. It's a little thicker on the bottom of the tank. And then obviously it's going to reduce the target wasting time to that. So that's kind of the pieces to the puzzle of this whole thing, and how this sheet is more than just a data entry sheet. It really can provide a bunch of guidance on operations and where we're at, where's the food to mass looking at, and just all the little different factors that go into this. And then where are we at? You can see here, although, we're pretty high here on the food to mass, that dropped down. Now we're a little low on the food to mass here, and can kind of help make adjustments for seasonal changes. And then obviously just averages and maxes and stuff like that, just for information points. Okay, well, that is it. Hopefully that helps. If you have any questions, don't hesitate to let me know. Thanks.